All right, we're going to continue with factoring trinomials. And in the last video, I kind of introduced what the standard form of a quadratic is. We're going to focus on quadratics, really. And when it comes to factoring trinomials, your goal is really to find the factors of a times c that sum to b. Remember, the standard form is ax squared plus bx plus c. We use the Berry method where you just take the first piece, whatever that is, and write it in both spots. And then you find these factors of a times c that sum up to b, and you put those in there. Then pull out any common factor. Don't write it out there, you're just pulling it out because you actually put in some extra pieces here. Let's go down and do some more examples. So let's look at this one, x squared plus 10x plus 25. All right, I'm looking for, if I know that a is what's ever in front of here, 1, b is positive 10, c is 25. I just like to write those down. I know that a times c is 1 times 25, or 25. If I find factors of 25 that add up to 10, I know that's 5 times 5, right? Both are positive. Now, this is the only part that sometimes people struggle with, is finding factors that add up to the middle. So that's just going to take some practice. That's just going to take some practice. But now that I've kind of done that part, I can use the Berry method. Whatever this is right here, if there's a number there included, I write it in here. In this case, there is no number in front, so I just write x and x. Now I take these pieces that I found, a positive 5 and then a positive 5. Those are my two pieces. I can't pull anything, a common factor out of here. I can't throw away a common factor out of here. I'm done. All right, let me move on over here. Same idea. I know that A is 3, B is 8, C is 5. I need factors of A times C, which is 3 times 5, or 15. Factors of 15 that add up to 8. Well, 3 times 5, that gives me 15 when I multiply. It gives me 8 when I add. There I go. Let me go ahead and start my factoring. The Berry method says whatever this is, write it in both places. Now I write in my factors. I have a positive 3 and a positive 5. A positive 3, a positive 5. I would say I'm done, but can I pull out a 3 here? So I just like to write the 3 there just to help me know that I'm dividing it out. So after doing that, 3x divided by 3 is just x, because 3 divided by 3 is 1, plus 3 divided by 3, or 1. Now here, I can't pull anything out, so I just rewrite that. And I'm done. I'm going to keep powering through. Let's take a look at this one. I see that A is 5, B is negative 1, C is negative 4. That means A times C is 5 times negative 4, or negative 20. I need factors of negative 20 that add up to negative 1. Well, I know 5 times 4, I might be able to combine those to get a negative 1. If I make this one a negative, then when I multiply them, I get negative 20, check. When I add them, I get negative 1, check. Again, that might take some practice, and that's where all these practice problems come to play. But for right now, for our purposes, we can start our factoring. Whatever this is, write it in both places. 5x, 5x. Now I know my pieces are negative 5, and positive 4, positive 4. But wait, I recognize that I can pull out a 5. So if I pull out a 5 from here, I'll get x minus 1, because 5x divided by 5 is just x, and 5 divided by 5 is just 1. Here, I cannot pull out anything common, and so I just write this as it is. And let's just see if I can do this one quickly as well. A times C is going to be negative 20, because it's 4 times negative 5. I need factors of negative 20 that add up to 8. That's going to be 10 times negative 2. And so I can break it down that way. I'm going to run out of time, but you can continue this.